Hello everyone. Today let us see Valency crisscross method in order to write a chemical formula. First let us see the definition of valency. Valency is the combining power or combining capacity of an element. Valency can be used to find out how the atoms of an element will combine with the atom of another element to form a chemical compound. The valency of an ion is usually equal to the charge on the ion. For instance, if I write the ion as H plus, this is actually called as proton. If I write the ion as H plus, it carries plus 1 charge. So the valency of this H plus is plus 1. Suppose if I write chlorine minus, then it means that it is carrying a negative charge and the valency of chlorine is also 1. So we write the charge as minus 1. Now, in order to understand the valency of ions, first we should know the names, the symbols of some ions. These ions can be classified into three types: ions of metallic elements, ions of non-metallic elements, and polyatomic ions. First, let us see the ions of metallic elements. The first one is sodium. Sodium symbol is Na. It is having a charge of plus 1. So we write the symbol as Na plus. For potassium, it is K plus. It is also having a valency of 1. Silver, Ag plus. This also has a valency of 1. And copper 1, copper has two valencies. It can either have Cu plus or it can have Cu2 plus. Now coming to magnesium. Magnesium has a valency of 2, so it is usually written as Mg2 plus. For calcium, it also has 2 plus valency. For zinc, 2 plus. For iron, Fe2 plus. And for copper, already we have discussed that copper has two types of valencies. Either it can be plus 1 or it can be plus 2. Whereas for iron, it can have two valencies. Either it can have Fe2 plus or we can have Fe3 plus. Now let us understand the valency of aluminium. Aluminium has a valency of 3 plus. So it is usually written as Al3 plus. So this is regarding ions of metallic elements. These are all metallic elements. Now let us move on to ions of non-metallic elements. In case of non-metals, first one is hydrogen. Hydrogen has got two valencies. Either it can exhibit as H plus or H minus. Hydrogen is called, H plus is hydrogen, whereas H minus is called hydride. It is called as hydride. Next we have the halogens. Chlorine, Cl minus. Bromine, Br minus. Fluorine, F minus. Iodine, I minus. Next we have oxide. Oxide valency is 2 minus. Sulfide is S2 minus. Then we have nitride, N3 minus. Phosphide, P3 minus. Hope you understood till this. These are the ions of non-metallic elements. These are all non-metals. Hydrogen, chlorine, bromine, fluorine, iodine, oxygen, sulfur, nitrogen, phosphorus. They are all non-metals. Now let us move on to polyatomic ions. Polyatomic ions are nothing but it will not be made up of a single atom. It will be made up of more than 3-4 atoms. So for example, for ammonium we write as NH4 plus. So the valency is plus 1 here. Next we have hydroxide, OH minus. Next we have nitrate NO3 plus 3 minus, sorry, NO3 minus. This is nitrate ion. Next we have hydrogen carbonate, which is also called as bicarbonate, HCO3 minus. This charge is for the whole, all the atoms together. It is not only for hydrogen here, hydrogen minus, it is for the full ion. It is NO3 minus, HCO3 minus. Now coming to carbonate. Carbonate is CO3. It has got a charge 2 minus. Sulfate is SO3 and it also has got a charge 2 minus. Sulfite, this is sulfite. Sulfate is SO4 2 minus. Both sulfite and sulfate has got 2 minus charge. Whereas phosphate PO4, this has got a charge of 3 minus. That's all regarding valency of polyatomic ions. Now let us move on to writing a chemical formula. So there are some rules for writing the chemical formula. The first rule is the valencies or charges must be balanced. They must be balanced. Second, if a compound consists of a metal and a non-metal, the symbol of the metal is written first, then the non-metal is written. For example, if I write calcium oxide, here calcium is the metal, whereas oxygen is the non-metal. Third one is when compound is formed with polyatomic ions, the ion is enclosed in a bracket. For example, for calcium hydroxide, we write CaOH twice. Here OH is hydroxide ion, which is a polyatomic ion. So such type of ions must be written inside a bracket. So these are the three rules. The first rule is valencies must be balanced, or the charges on the ion must be balanced. The second one is when the compound consists of a metal and a non-metal, the symbol of the metal is written first and the non-metal is written next. For example, calcium oxide, sodium chloride, all the compounds, we can see that the metal is written first and the non-metal is written at the last. And the third rule is if a compound contains polyatomic ions, the ion should be enclosed inside a bracket. For example, calcium hydroxide. Suppose if the number of polyatomic ion is 1, if the polyatomic ion is 1, then we need not write inside a bracket. For example, in sodium hydroxide, we know that hydroxide is a polyatomic ion, but since only 1 is here, we need not write inside a bracket. Now, to write the chemical formula for simple compounds, these 4 steps are followed. These are the steps. First step is write the symbols. Write the symbols. And then at below write their valencies. Second step, write the symbol of cation followed by the symbol of anion. So first we will write the cation, then we will write the anion. Third step is then crisscross their charges. Crisscross their charges or valencies to get the formula. Fourth one is the positive and negative charges must balance each other. So balancing must be done. And the overall structure must be neutral. The simplest compounds made up of 2 different elements are called as binary compounds. So one definition we can learn here. The simplest compound which are made up of 2 different elements, they are called as binary compounds. So let us see the chemical formula by crisscross method of binary compounds. The first one we are going to find out here is hydrogen sulfide. Hydrogen sulfide. Now, the first step, write the symbol. So, for hydrogen it is H, for sulfide it is S. Then write the charge. This is symbol. Next, we have to write the charge below the symbol. For hydrogen, we know that it is +1. For sulfide, it is -2. Now, third step is crisscross their valencies. So, hydrogen valency will be given to sulfur and sulfide valency will be given to hydrogen. Like this, crisscross the valencies. So, we will write hydrogen will become 2H2 and sulfur will become S1. So, when the subscript is number 1, that subscript is usually not written. So, the formula for hydrogen sulfide is H2S. Clear everyone? Let us move on to the next formula, carbon tetrachloride. Carbon tetrachloride. Okay. The symbol for carbon is C, of course. For chloride, it is Cl. For carbon, the valency is +4. Okay, we did not discuss about carbon while discussing about ions of non-metallic elements. Carbon has a valency +4. That is why it involves in catenation and forms large number of organic compounds. Chlorine has a charge of -1. Now crisscross. So this +4 will go to chlorine. This -1 will go to carbon. So we will have C will be only 1. So I said that if we have subscript 1, we will not write that. Then chlorine will have a subscript 4. So this is the formula for carbon tetrachloride, CCl4. Next, we will see for magnesium chloride. So magnesium is symbol is Mg. For chlorine it is Cl. For magnesium it is +2. For chlorine it is -1. Crisscross their valencies. MgCl2. This is the formula of magnesium chloride. Let us see for calcium oxide. For calcium, the symbol is Ca. For oxide, it is O. For calcium, it is +2. For oxygen, it is -2. So, the formula will be Ca2O2. Since both the subscripts are same and it can go in the same table, when we simplify, we will get CaO. So, when the valency of both the elements are numerically equal, the subscripts are not written. So, instead of writing Ca2O2, the formula for calcium oxide is CaO. Now, let us see for aluminium oxide. Aluminium symbol is Al. For oxide, it is O. For aluminium, it is +3 charge and the charge for oxide is -2. Let us crisscross their valencies. We get Al2O3. So this is the formula for aluminium oxide. Now let us write the symbol for sodium nitrate. For sodium it is Na. For nitrate it is a polyatomic ion. So we write as NO3. Sodium it is +1. For nitrate it is -1. So when we crisscross the valencies, we get NaNO3. Since the subscripts are 1, 1 and since the polyatomic ion is only 1 here, we need not write in bracket. So the chemical formula for sodium nitrate is NaNO3. Let us see for potassium carbonate. For potassium, the symbol is K. For carbonate, the symbol is CO3. For potassium, the charge is +1. For carbonate, it is -2. So, when I crisscross, exchange the valency, I get K2CO3. Since it is 1, the subscript is going to be 1. I need not mention. And this polyatomic ion is only 1 here. So it is K2CO3. Potassium carbonate is K2CO3. Whereas for sodium carbonate, sodium Na carbonate CO3 plus 1 charge. For carbonate it is minus 2. Crisscross their valencies. We get Na2CO3. This is sodium carbonate. This is commercially known as washing soda. Next, aluminium hydroxide. Aluminium hydroxide. For aluminium it is Al. For hydroxide the symbol is OH. Now it is a polyatomic ion. Here aluminium charge is plus 3. Whereas for hydroxide it is minus 1. So when I crisscross, I will get Al. Minus 1 we need not mention since it is 1. OH. Now this has got a subscript 3. So let us write it inside the bracket. So the formula is AlOH thrice. This is the formula for aluminium hydroxide. Okay. Let us go for ammonium sulfate. For ammonium, the symbol is NH4. For sulfate, it is SO4. For ammonium, it is minus 1. But for sulfate, it is, for ammonium, it is plus 1. For sulfate, it is minus 2. So when I crisscross, I will get NH4. This is also polyatomic. Ammonium is also polyatomic. Sulfate is also polyatomic. So both, we need not write in brackets because sulfate is only 1 is there. So only ammonium will write in the brackets since 2 ammonium ions are there. So NH4 twice SO4. Now coming to tin oxide. Tin symbol is Sn. Oxide symbol is O. For tin it is plus 4. For oxide it is minus 2. When we crisscross, we get Sn2O4. Now since both these numbers can be reduced, they will go in the same table. So we will get SnO2. So this is the formula for tin oxide. With this, we will stop. You can let me know the molecular formula for magnesium sulfate. Mention in the comment box what is the formula for magnesium sulfate, sodium bromide, calcium chloride, potassium nitrate. Sodium phosphate. With this, let me conclude today's class. You can suggest what you want to learn in the comment box. Thank you.